Okay, so lecture 5, continuation of the singularity function. Okay, so in previous class we have seen the input impulse, unit impulse, unit step, unit ramp. Okay, and some integration and differentiation property of the these singularity function. Okay, so in continuation, another signal is your sinusoidal signal. Okay. Most probably you have heard about these signals because labs में सबसे ज़्यादा आपने इसी सिग्नल को यूज़ किया. Okay, so the generalized function or generalized form of this sinusoidal signal is xt equal to a sine omega t plus phi. Okay, this is generalized form where a is your amplitude, omega is your angular frequency, in radian, and phi is the phase angle in radian. Okay, so if I want to plot the, so you can plot in this manner. I'm just considering phi, any phi value. So let's see, that is your xt and t is varying from. So let's see, the signal is coming in this manner. Okay, so I'm just considering any phi value here. Phi. Okay, and the this value is, let's see, just making this further. So t equal to 2 pi upon omega, that will be the period of this. Okay, so जो period आपका होता है, that is the continuous time sinusoidal का, it is given by t equal to 2 pi upon omega. Okay, time period. Now suppose this phi is 0, इस phi की value आपने 0 ली, so it is understood now the signal is, you're going to start from this point. Okay, so I'm just considering any phi, generalized form की phi की कुछ value है, so that's why it is starting from this point. Okay, so please keep this thing in your mind. Now same, that is the in the form of t, analog or continuous form. अगर मैं बोलता आपसे यही कि let's see, same will be, what will be the equation in terms of when the signal is discrete form. So आपको पता है t की जगह you have to replace with the n. So a sin omega n plus phi, सैंपल्स की वैल्यू आ जाएगी. ओके, ना जो इम्पोर्टेंट पॉइंट यहाँ पे है वो आपको ये ध्यान रखना है कि जो हमारे पास साइनसॉइडल सिग्नल्स होते हैं, ठीक है, सो all continuous, you have to remember this point, all continuous time sinusoidal signal short form लिख रहा हूँ, sinusoidal signals are periodic. Okay, I think we have learned about this periodic, non-periodic signal. We will see in further lectures. So periodic, but यहीं पे आप important point है, but discrete time sinusoidal signal or you can say sequences may or may not be periodic depending upon the value of omega. Okay, if this omega equal to 2 pi, then you can say that this discrete time signal is periodic. Otherwise, reason क्या है? Reason you know कि suppose यहाँ तक मैंने डेटा लिया, मैं इसी में डिजाइन कर देता हूँ, ये वैल्यूज मैंने बना दी डिस्क्रीट के लिए. ओके, नाउ अब आपका जो सिग्नल है वो यहीं पे फिनिश हो गया. सो यू कैन सी ये साइकिल अपनी कंप्लीट ही नहीं कर पाएगा. मीन्स ये वाला पोर्शन आपका रह जाएगा. सॉरी. और जब ये रह जाएगा तो आपका जब साइकिल ही कंप्लीट नहीं होगी तो यू कैन नॉट से दिस इज अ पीरियडिक सिग्नल. ओके, सो दिस इज द about your sinusoidal signal. Now the next one is exponential. In exponential we will see one is real exponential and second one is the complex exponential. So short form में quickly मैं आपको बता देता हूँ. Real exponential signal. So in this type of signal, the generalized form is given by xt equal to a e to the power alpha t, where both a and alpha are real. Okay, now so from here you can see, suppose if I am putting the value of this alpha equal to 0. Okay, if I am putting alpha equal to 0, can anyone tell what will be the signal?
8.
Step function that will be. Okay, but that is lying from the minus t to plus t. Okay, because alpha equal to this 0, e to the power 0, that is equal to 1. So xt equal to a obviously will be some amplitude, so you will get in this form, and the value of this is a. Yes, okay, here t minus t. Okay, so for alpha equal to 0, you can see the signal होगा constant amplitude, constant amplitude for all the times, for all the values, t values. Now, if alpha is positive, in this case means alpha greater than 0, xt will be is a growing signal, growing exponential signal. Okay, means if you draw this, so you will get the in this manner when the this is the xt when alpha greater than 0. Okay, and the value of xt is your a e to the power alpha t. Okay, and obviously at a equal this point t equal to 0, the magnitude is a. Now, when the alpha is negative, or you can say alpha is less than 0. So for this, xt is a decaying exponential signal, or you can draw in this manner. मीन्स टाइम के साथ ये डिके होता जाएगा. That is your xt, and that is your value for when alpha is less than 0, and at this point value will be a, and it is moving. Okay, so remember these things, these two graphs, they are very important. Okay, now same will be in the case of the discrete. Okay, discrete mein now you have to, rather than drawing this overall, just draw in this manner. So that will be like as. Okay, so decreasing and increasing, both you can design very easily. Okay, sorry. Now next one is the complex. Suppose you have complex exponential. That was the next one is the complex exponential signal. Means now this xt equal to a e to the power st, where this s equal to sigma plus j omega. Okay, because that is the complex form. इसके पहले मैंने देखा था both are real, a and alpha दोनों थी. Okay, so for this, if you want to draw the figure, okay, s की value just put, so you will get the xt equal to a e to the power sigma plus j omega t. Okay, and you can here find out the real and imaginary parts separate, e to the power sigma t small t and e to the power j omega t. Okay, And I hope all of you know about this form a e to the power sigma t, and you can write it down e to the power j omega t equal to cos omega t plus j sin omega t. Clear? So now if अगर मैं आपसे बोलता हूँ now draw this signals, okay, if s equal to 0, so obviously if you are putting s equal to 0, you will get again a constant value. If s equal to your minus omega, okay, only s equal to minus j omega, मैं यहाँ पे ड्रॉ कर देता हूँ तीनों कॉम्बिनेशन. So first case, this is the A graph when s equal to 0, and this is your xt. Second one, B plot, draw yourself, okay, so you will find out what is happening here. S equal to, when this is your minus sigma, we already seen this type of structure before, graph, and when this s is plus, so that will be increasing when s equal to sigma xt. Here is t. Okay, now next, if I am saying this s equal to, अभी मैंने क्या बनाया, जो रियल पार्ट था उसकी वैल्यूज लेते हैं, ओके, क्योंकि आपके पास फंक्शन क्या है, e to the power sigma plus j omega t. Okay, means imaginary part यहाँ पे we were considering the zero value. So if the value is now sigma is 0, only imaginary part is available. In this case, obviously you will get, sorry, xt when s equal to plus minus j omega. क्या होगा, कोई बताएगा? If I am taking s equal to plus minus j omega, anyone? You know the function xt equal to e to the power a e to the power st, and if you are considering s equal to plus j omega or minus j omega, so in the first case you will get the sinusoidal signal. That is an improper sinusoidal signal, but it will be the case when this s equal to plus minus j omega. In second case, when you are considering s equal to xt sigma plus minus j omega, but the condition is alpha less than 0. So you will get the sinusoidal but in the decreasing manner. in this manner. And same will be opposite case when you are considering third one, and s equal to sigma plus minus j omega, but the alpha is greater than 0. So you will get the sinusoidal in increasing order. So these are the all about your exponential function. Okay. Now the next one is important. I'm just writing the function and the graph. Okay. Next one is the signum function, or you can say signum signal. So this is represented by sign t, and 1 when this t greater than 0, and minus 1 for t less than 0. So if you want to draw this graph for this signum t, sgn t, this is sgn only. ओके मैं यहाँ पे लिख देता हूँ SGN. So obviously plus 1 and valid for minus 1. This is the signum function. Okay. Next one is also very important function. Okay, when uh, in coming semester you will read about this TSP and communication, digital communication, and analog communication. You will see this type of function. Okay, so next one is the sync function. Okay, so the mathematical function of this sync is sync t equal to sine t by t for minus infinity to plus infinity. T is varying minus infinity to plus infinity. Okay, आप में से कुछ लोगों ने ये शायद फंक्शन देखा भी होगा. Okay, that is symmetrical around both the axes. Okay, ये कुछ शेप ऐसे आता है जो बाय मिस्टेक गलत बन गया. Okay, so that is your sync function. sync t लिखते हैं इसे. Okay, next one is also maybe ये आपसे नहीं पूछा जाए, but when you will learn about this wireless communication, so you will see this Gaussian function. Okay, that is your Gaussian function or Gaussian signal. Okay, so that is represented by Gaussian e to the power minus a t square for minus infinity to t to cosine. Okay, so these are the some important signal or functions are available in your subject, and we will solve some numerical problem based on these functions. Okay.